In this video, I'm going to be explaining how to find intercepts algebraically. We can start with defining what's called the general form of a linear equation. This is representing a line. A is the coefficient of x, B is the coefficient of y. They're just numbers that are going to be in front of those variables. C is also going to be a number. So for example, this is an equation in general form. -2, 4, and 8 are not anything special by themselves, but we can manipulate this formula and put it into a different form, and then we could talk about some special things like slope or y-intercepts. We can actually just leave it in this form to find x and y intercepts. Here's how we do it. To find the y-intercept, we learned in a previous lesson that the x value of a y-intercept is always 0. If I'm on the y-axis, I haven't moved left or right on the x-axis, so my x value is always 0. We can use that. We're going to set x equal to 0 if we're going to be on the y-axis. So doing that cancels this term altogether, and we're just left with the y term, which is what we want to solve for. So if we solve this equation for y, we divide both sides by 4, or multiply both sides by 1/4, and we get y equals 2. So if my x value was 0, my y value is 2, that is on the y-axis, that's a y-intercept. Similarly, we can solve for the x-intercept, but instead substitute 0 for y, because if I'm on the x-axis, I haven't gone up or down, so my y value is 0. So anytime you solve for an x-intercept, your y value is always 0. We can use that and set y equal to 0, canceling that term, leaving the x term, which is what we want. -2x equals 8. To solve that, we would divide by -2 or multiply both sides by -1/2 and get a solution for x. X is -4. So now we know that our x value was -4 when our y value was 0, placing us on the x-axis. That's our x-intercept. In the next example, we're going to take our x and our y-intercept, and we're going to plot them and actually draw the line just using the intercepts. So it is true that this is an equation of a line that we could solve for y, put it into slope-intercept form, start with our y-intercept and use our slope to get other points. But we can also graph using intercepts, so let's practice that. So take this equation and find the x-intercept. To do that, we cancel our y by substituting 0, and then solve for x. So 2x equals 18. We can divide both sides by 2 or multiply by 1/2, and we get x is 9. So x is 9 when y is 0. That's an x-intercept. Let's solve for the y-intercept. Let's substitute 0 for x, so we cancel that term, and then solve for y. So when -6y equals 18, we could divide both sides by -6 or multiply both sides by -1/6 and get our solution y equals -3. So when x was 0, y is -3, placing us on the y-axis at a y-intercept. So we can plot those 2 points. If I plot 9, 0 on the x-axis, and I plot 0, -3 on the y-axis, we can just connect those 2 points, and there's the line represented by this equation. If we solved for y and put it in slope-intercept form, we would end up with the same line. So this is just a different version of that equation. One more example. What if it's not in that general form? Well, we can always substitute x is 0 and solve for the y-intercept, or y is 0 and solve for the x-intercept in any form. We don't have to put it in general form. General form is just a lot more helpful. So either you spend more time or more steps putting this equation into general form, or you spend more time and more steps by substituting in this form and solving for x or y. It really doesn't matter. It's whatever you prefer. I'm going to practice putting it into general form, though, and solving for our intercepts. So to put it into general form, I need my x's and my y's on the same side. So I'm going to put 2y over on the other side by adding it to both sides. Now I have my x's and my y's on the same side. This is general form. So now it's set up to just plug in 0 and solve for the other variable. So if I want to solve for the x-intercept, substitute 0 for y, cancel that term, and then solve for x. Negative 12x equals negative 8. It means I'm going to divide both sides by negative 12 or multiply both sides by negative 1/12. When we do that, we get negative 1/12 times negative 8 over 1, giving us a positive 8 over 12, which reduces, divide top and bottom by 4 and get 2/3. So the x-intercept is at 2/3, 0. If y is 0, x is 2/3. If I wanted to graph this or draw it on a 10 by 10 graph, you could just estimate and place this in between 0 and 1. Solve for the y-intercept, substitute 0 for x, and solve for y. So cancel that x term, solve for y. We divide both sides by 2 or multiply both sides by 1/2, and we get y equals negative 4. So if x is 0, y is negative 4, giving us our y-intercept. So we could plot these 2 points, connect the points, and we could draw our line. So there's how we solve for intercepts algebraically using general form.